Okay, so we're moving on to section 3.4, which is exponential and logarithmic equations. So we're going to explore how we can solve exponential and log equations. The first example I wish to go over is an example where you have to equate the bases. So for instance, as you see in example 1, it says they want you to solve this equation. It says 16 to the x plus 3 power is equal to 4 to the 4x plus 7 power. So this is the method you should always try to use first. So if you can make the bases the same, you should always try to do that as far as solving exponential and log equations. So what I'm going to do is rewrite 16 as a power of 4, because that way I can make the bases equal. And I'm going to write 16 to the x plus 3 as 4 squared to the power x plus 3. And I'm going to say that that is equal to 4 to the 4x plus 7. Now I can multiply both x and 3 by 2, and I can rewrite that expression as 4 to the 2x plus 6 is equal to 4 to the 4x plus 7. And once I have done that, because my bases are the same, I can cross out the 4's and just say that 2x plus 6 is equal to 4x plus 7 is and now I can just just solve, sorry. And I can say that negative 1 is equal to 2x, or x is equal to negative 1/2. Once I have that, I should always check and see if that's a true statement. So if I raise 16 to the negative 1/2 plus 3, so if you check 16 to the negative 1/2 plus 3 should be equal to 4 to the 4 times negative 1/2 should be negative 2 plus 7. And I know that this is going to give me 5/2. So 4 squared to the 6 minus 1 is half to the 5/2 should be equal to negative 4 to the 5th power, and it is, so it works. Okay. So for the next problem, let's see what happens here. Let's make that bigger. Okay. So for this one now, you have 2/3 is equal to 2/3, so the x minus 5 power is equal to 9/4 to the 3x over 4. So the first thing I'm going to do is I am going to see if I can equate the bases. So in this case here, I can write 2/3. There's not much I can do, so I'm going to leave it alone. 2/3 to the x minus 5 power is equal to, and I know that 9/4, I will do a little work on the side here. I know that 9/4 is 3/2 squared, right? Because 3 squared would be 9 and 2 squared is 4. But I don't want 3/2, I want 2/3. So I am going to rewrite that as 2/3 to the negative 2 power. So now I can write it down here and say that this is equal to 2/3 to the negative 2 power, and that whole thing, it can be raised to 3x over 4. So now I'm in good shape. I can say that, no, not again. Okay. I can say that 2/3 to the x minus 5 power is equal to, and now I'm going to have to multiply those. So that is equal to 2/3 to the And negative 2 times 3x over 4 is the same as negative 3x over 2. And once I have that, I can just cross out the bases because they're the same. So now I can say that x minus 5 is equal to negative 3x over 2. And what I'm going to do is multiply both sides by 2 to get rid of that fraction. And I get that 2x minus 10 is equal to negative 3x. So now I can go on and say that minus 2x minus 2x. So I can say that negative 10 is equal to negative 5x divided by negative 5. And you get that x is 2. Now remember, should always check. So if x is 2, when I go back here, I should see that 2/3 to the 2 minus 5 is equal to 9/4 to the 3 times 2 over 4, which would just be 3/2. So now I am left with 2/3 to the negative 3 is equal to, remember, this is 3/2 squared. So 3/2 squared to the 3/2 should be just equal to 3/2 to the third. And that works because you just flip and make the exponent positive. All right. So your answer here should be 2. Okay. Moving on. Okay. So that was 1A, 1B. Let's see. Okay. So now we move on to 2A to B to C. So 2A, they want you to solve that equation. It says negative 3 natural log x equals negative 24. So it appears to me that the easiest route to take would be just to divide both sides by negative 3 first. And those will cancel out. So you get natural log x is equal to 8. Now remember, the inverse of natural log is e. So you can e both sides. Those will cancel out. And they're left with x being equal to e to the 8th. So that you can just put on the calculator, and we so now 1 second, please. Okay. Sorry about that. Yeah. Okay, so now when you evaluate that, e to the 8th power, you can just put that on the calculator. And when you put that on the calculator, you should get about 2981. So x is equal to 2981. Okay? So moving, not again. All right, so now let's take a look at 2b. So for 2b, my first step would be to subtract 4 from both sides. you get negative 3 log 5x is equal to 12. And once you have that, you can just divide both sides by negative 3. And you're left, this cancel out, log 5x is equal to negative 4. And you can use the definition of a log, or you can just do a base 10 to both sides. I'm going to use the definition of a log for that. Remember, the base of a common log is 10. So I can say that 10 to the 4th power, I'm going to say that 10 to the 4th power, oh no, okay, here we go. 10 to the 4th power is equal to 5x, or negative 4 power, I'm sorry, which means x should be equal to 10 to the negative 4 power divided by 5, which is about 0.00002. So your answer would be 0.00002. That would be the answer. Okay. One more as far as this goes. And so I'm going to say, I'm going to take a look at 2C. So for 2C, for this one also, again, I think you can just use the definition of a log. So the base to that exponent equals that. So I can say that 3 to the 4th power is equal to x squared minus 1. 3 to the 4th power is 81. So I can say that 81 is equal to x squared plus minus 1. Add 1 to both sides. And then you get that x squared is equal to 82. Square root both sides, and you get that x is equal to plus minus square root of 82. And x would be about, if you put that on the calculator, you get 9.06. So plus minus 9.06. Okay. All right. We're almost done for today as far as these go. So now we take a look at the third type of equations. And these are rather friendly because you can cancel out the bases. So in this case, you can cancel out the log base 6. You're left with 2x is equal to x squared minus x plus 2, which means if you subtract 2x from both sides, you get x squared minus 3x plus 2 equals 0. You can just straight factor this. So the two factors would be negative 2 and negative 1. So x minus 2, x minus 1, x minus 2, x minus 1 equals 0. So x should be 2, x should be 1. You should always check. In this case, they both work because log base 6 of 2 is equal to log base 6 of 1 squared minus 1 is 0 plus 2 is log base 2. So 1 works. If you try 2, that also works. Log base 6 of 2 times 2 is 4. Log base 6 of 4 equals log base 6 of 2 squared. 4 minus 2 is 2. 2 plus 2 is 4. So both of these work. You should always check. Okay. And then for this one, and then we stop for today. The only thing you need to remember here that is very, very important is that if you have two logs like this, you need to condense first. So condense first. Okay? So you get log base 12 of x plus 3 is equal to log base 12. And now remember that's going to change to multiplication. So it becomes 4x. Now you can cancel out, and you get x plus 3 is equal to 4x. And your answer should get 3 is equal to 3x. So x is 1. Once again, you should always substitute into try, but this one does work. Thank you. That's all for today. We'll finish this section tomorrow. Thanks so much.